Alright, so today I'm going to talk about the basic physics involved in the flight of a disk from the windup to its descent back to Earth. During the windup, you're going to be building up momentum as you move forward, and you're going to apply a torque to the disk as your body rotates. The disk is going to act as a projectile object, and overall, it's going to show a transfer of kinetic energy to gravitational potential as it hits its apex, and then back to kinetic energy on its way down. So the shape of the disk is convex on top and concave on the bottom. This is going to make the airflow on top greater than the airflow on the bottom. So velocity on top is greater than velocity on the bottom. There's also an inverse proportion between velocity and pressure of air systems. So because the velocity on top is greater than the velocity on bottom, the pressure on top is going to be lower than the pressure on bottom. And this is going to generate lift and keep this disk in the air longer than, say, a ball. Now, the way the disk flies is a little different than most objects, in that it's moving with linear velocity as well as rotational velocity. We'll call linear velocity V and rotational velocity T. So it's moving forward with V, spinning with T. The leading wing is going to be moving forward with V and forward with T, while the lagging wing is going to be moving forward with V and backwards with T. And because of that inverse proportion of V is inverse to P, pressure, the net velocity of the leading wing is going to be higher than the net velocity of the lagging wing, meaning that the pressure of the leading wing is going to be lower than the pressure of the lagging wing, causing the disk to tilt to the right and fly to the right. Now I'm going to show an example of this by throwing this.